Hello everyone, welcome back to the channel, and today let's talk about OSPF configuration. In this practical, we are going to implement OSPF on a single area where this PC1 here should be able to talk to PC2. We are going to advertise the networks on each and every router on this network. Also, we are going to configure OSPF on interface-based cost configuration where either of the routes you can either follow the route from router 1 on the headquarter to router 2 on the headquarter all the way to the router on the branch side, or you can follow from router 1 to router 3 to router to the switch and to router 4. The reason why we configure OSPF on interface based cost is where, like, uh, when you send packet from PC1, it will select which one is the shortest path. As we all know that OSPF uses the shortest path tree algorithm, so it will check the route with the lowest cost and forward that packet through that route. Like for instance here, cost of 1 and cost of 10, so it will select cost 1 and forward it to router 2, then to switch 1 here. Switch 1 here, we won't configure anything on switch 1 here. Switch 1 will just act as the bridge through which the packets will just pass through. We will also implement what is called redundancy, router redundancy, that is the virtual router redundancy. We are going to configure the VRRP on these two routers, so that in case any of the interfaces of either the router of this active router goes down, the inactive router should take over the role of the active. So that is where we implement virtual redundancy, that is virtual router redundancy. So at the end of this practical, PC1 and PC2 should be able to ping each other. So this is very simple, and this is going to sharpen your mind on OSPF configuration. So you are going to see how the cost configuration works, how the router selects which route to forward the packets. So let's just jump into our configuration. So the first thing we are going to do is we are going to configure the interfaces and give them IP addresses. So interface gig 0 slash 0 0 slash 0 slash 0. I will give it an IP address of 10.0.0.1. This is a slash 30. Then you enter gig 2, gig 1. Gig 1 will give you an IP address of 10.0.0.5, subnet mask of 30. Then the interface that connect to PC1, you give it gig 2 and give you an IP address of 10.0.0, not 10.10.10.1, subnet mask of 24. After that, I do the same to this other router on this switch, on the router on the network up there. So interface gig 0 slash 0 slash 0 give you an IP address of 10.0.0.2 slash 30. Then IP address of that. Then interface gig 1 IP address of 10.1.1.1 slash 24. Then you come to this other headquarter router here. This other headquarter router here. So system view. So enter interface G0/0/0 IP address of 10.0.0.6, a mask of 30. Then gig 1, IP address of 10 dot IP address of 10.0 10.1.1.2, a mask of 24. Then we go to router on the branch. So this practical, this router 1, router 2, router 3, and switch 1, they are on the headquarter network. Then router 4 here is on the branch network. So after we configure the OSPF, in our next practical, we are going to configure the VPN, so that we are going to enable remote users, that is on the branch side, to be able to access the headquarter networks in a secured channel. So at the end of this chapter, make sure you follow the next video. It will be talking about the VPN, how you can configure VPN between the headquarter and the branch network. So we enter into that router. Also, you configure the layer 3 parameters. So interface gig 0/0/0 IP address. You're going to give it IP address of 10.1.1.4/24. Then the interface that connect to the down PC1. So that is gig 1. Gig 1, you're going to give it IP address of 20.20.20.1, subnet mask of 24. After that, you come into these PCs. Also you give them IP addresses. So this is 10.10.10.10. The mask is 20/24, so that is 255.255.255. The gateway will be that interface on the on the router 1. So gateway, we are going to give it 10.10.10.1. That is interface gig 1 IP address. Then we apply and come to this other PC2 here. You also give it an IP address. So we are assigning IP address manually. So 10.10.10. I mean 20, not 10. This is 20.20.20.10. The mask is 255.255.255, mask of 0, and then the gateway will be 20.20.20.1. That is the interface on branch router 4. That is the interface on gig 1. So after that, the next thing we are going to do, we want to make sure that PC1 should be able to ping to PC2. We are going to configure the routes. The OSPF should learn the routes of router 1 and router 3. So we come on wait, and on that router we are going to configure OSPF. Here we are going to use OSPF. We are going to use process ID of 10. Then area, we are going to use area 0 because this is a single area OSPF. So we are going to use the backbone area, so area 0. Then we advertise the networks. We are going to advertise the network for network of 10.0.0.0, a wildcard mask of 0.0.3. Because this is a /30, its wildcard mask should be .3. Then the next thing the next network we are going to advertise is the network that connect router 3. So network of 10.0.0.4 wildcard mask of 0.0.0.3. Then so that's this network. Let me show you. You see it. So that's this network. We are going to advertise this network here. Then lastly, we are going to advertise the network that connects to PC1. So network of 10.10.10.0 slash a wildcard mask of 0.0.0.0.255. After that, save your configuration. Then the next thing we do, we advertise the network on router 2 here. So you quit and OSPF process ID of 10. The area, this is area 0. In area 0, we advertise the two networks, that is the network of 10.00 and the network of 10.11. So network 10.0.0.0, wildcard mask of 0.0.0.3 because it's just /30. Then we advertise the network of 1.1. So you can see that interface has exchanged the LSS. Then the neighbor state is full, as you can see here. So the neighbor state is full. Yeah, the neighbor state is full. The next network we are advertising is a network of 10.1.1.0, wildcard mask of 0.0.0.254. This is .255. This is .255 because it's a /24. Enter that. After that, you come on this. Sorry, let's go back to this router 1 here. We didn't configure OSPF on the OSPF cost on the interface. So interface G0 /0/0 OSPF cost. We are going to give it a cost of 1. So we give it cost 1. Then interface gig 1, the one that connects to router 3, you give it OSPF cost of, this one you give it an OSPF cost of 10, so that it will be selected as the backup. So you all know that SPF algorithm uses the lower the cost, the higher the preference for that route. Then you come back to this router here also. You configure the cost. So quit and quit. Enter interface gig 0/0/0 OSPF cost of 1, and interface gig 1 also give you an OSPF cost of 1. Then we come back and we configure router OSPF on router 3 here. So if this interface has a cost of 1, this interface also has a cost of 1. So when you add the interface, the total cost will be we add the outbound interface. So cost of 1. So when you add that, the total cost will be 2. But when come this side, the cost of 10, the total cost will be 20. So the most preferred cost will be cost of 2. So you come to router 2 here, router 3 here. We also configure OSPF. So quit and OSPF process ID of 10. I give it area 0. In area 0, we are going to address the network of 10.0.0.4, wildcard mask of 0.0.0.3, and LSS. You should see the LS being exchanged. So the LS have been exchanged, and the neighbor state is the current neighbor current state is full. Then we advertise our last network of 10.1.1.0, wildcard mask of 0.0.0.255. LSS should be able to be exchanged. Yeah, it has exchanged the LSS. Then you create and enter the interface view and add the cost. So interface G0/0/1/0, give it a cost in OSPF cost of the OSPF cost. We are going to give it an OSPF cost of 10. Then the same to gig 1. Gig 1 also we give it an OSPF cost of 10. After that, I save the configuration. Also come here and you save the configurations. After that, after configuring the OSPF, what we are going to configure now is the virtual router redundancy. So these two routers are going to implement the VRRP. So one is going to act as the master, and then the other is going to act as the backup. So enter into that. So SY system name. So enter interface. The interface that where we are going to configure the VRRP is the outgoing interface, the outbound interface. That is gig 1. So interface gig 0/0/0/1. Display this. See if it has an IP address. Okay, it has an IP address, and the cost has been enabled on that interface. So after that, what we do is enable VRRP. So VRRP VRID of 10. The VRRP group is 10. Then the virtual IP is 10.0 10.1.1.3. Then VRRP VRID 10, and the priority we are going to set to 120 because it's going to act as the master router. After that, VRRP we give it the preemption delay. VRRP VRID 10 preemption mode timer. We set delay to 20 seconds. After that, we display and see. Okay, then I configure it on this other router also. So interface G0/0/1 display and see if it has an IP address. Display this. Sorry for that inconvenience. So let's go back. Let's continue that. So display this. So that interface has an IP address. After that, what we are going to do next is now configuring the VRRP. So VRRP VRID of 10. The virtual IP, I will give it a virtual IP of 10.1.1.3. Then because this is going to act as the backup, so we're going to give it a priority of VRRP VRID 10 priority of. This is a priority. We're going to give it 90 because the other one we gave it 120. So this one, the higher the priority, the higher the preference. So after that, display this. Display this and see. Okay. Wait, and let's display VRRP. When you display VRRP here, you see this one is acting as the backup, and the master is 10.11 on the other one. Then the master has a priority of 120, the one that we had configured. So the VRRP has been configured, so meaning that router 2 here is going to work as the master. This one goes down as the backup. In case a link that connects to router 2 here goes down, the links that connect to router 3 should take over the packet forwarding. So we've configured the OSPF to advertise the routes. We've also configured the VRRP. So let's now configure, we want to configure static routes from these two routers here to the network on the branch side here, and also from the branch side here we are going to tell it the network where PC2 here belongs. So you enter into that quit and IP route static. You're going to advertise a network of 20.20.20.0, mask of 24. Then our next hop is going to be .4. So our next hop will be 10.1.1.4. I do the same to this other router because they are implementing redundancy. Their configuration should be able to synchronize. So IP route static 10 route static 20.20.20.0. I'll get mask of 24. Then the next hop will be 10.1.1.4. Then you come to this other router here and try to configure static route to there. A static route we are going to configure, and its next hop will be the IP address of the virtual VRRP. So that is going to be IP route static. The route we are going to advertise is 10. That is on PC1, 10.10.10.0. Welcome mask of 24, and the next stop will be the address of the IP address of the VRRP. So .1.3. So let's see if we can ping from this router 1 and reach the interface of router 4. So ping 10.1.1.4. It can't reach that router. Ping 10.1.1.4. I should be able to reach, and can't reach that network. And what about meaning that this guy here can't reach the gateway on this network here, but while we are on these routers here we can reach that gateway. So ping 10.1.1.4 is able to reach. And what of if we ping 20.20.20.1, should be able to go. So this guy should be able, is also able to ping up to this interface. And can it reach that PC2? So PC2 is .10. So it's still able to ping. So from this point we are able to talk to this other guy down here. Let's display OSPF display OSPF peer brief. The neighbor is .2 and .6. The neighbor is .2 here and .6. And in this guy display OSPF peer brief. The neighbor is .1 and .2, and the state is full .1 and .2 here. And let's see, can this router here reach any of the interface on this router here? So let's try. So ping 10.0.0.5 and C or 10.10.10.1. It can't reach that. Network. The destination, it doesn't know about that destination. 10.0.0.5. It doesn't know about that destination. So the thing we are going to do, let's try to advertise the OSPF on this router here. Now you come here and you're going to advertise the OSPF. You're going to advertise the network on that router. So OSPF process ID of 10. The process ID of 10. After that, we give it area 0. So area 0, and area 0 we are going to configure the network of 10.1.1.0. So I'll get mask of 0.0.0.255. Then we also advertise the network that is on the PC1 here, the network of 20.20. So the network of 20.20.20.0, wildcard mask of 24, wildcard mask of 0.0.0.255. Now let's see if we can reach .1. Can we quit and let's see if we can ping that .1. Okay, we are now able to ping that interface on. While we are on this router here, we are able to ping the interface of this gig 0002 that connects to PC1. And on this side here, let's see if we can also ping the gateway of that network. So it's also able to ping the gateway of .4. And what of network of .20? So ping 20.20.20.1. It's able to ping. So our main implementation was that to implement OSPF so that PC1 here should be able to ping PC2. So we are going to PC1 here. We're going to PC1 here and see, can we ping PC2 that is on .10. So ping 20.20.10 and see if it's able to ping. Host unreachable, it's turning packets. Okay, let's reping again. Ping. So the ping is successful. As you can see, the ping is successful. 5 packets were transmitted, and 5 packets have been received with a 0% packet loss. And on this, see if it's a two-way, and on this PC2 here, can we also ping PC1? So ping 10.10.10.10. It's able to ping PC1. So that's the implementation here. That's how we configure OSPF and also the virtual redundancy. So on router one here, let's now display OSPF routing. In the OSPF routing, we can see the cost that we configure for that interface, and the cost for that is cost of 1 towards those networks. After that, what else do we need to check? Okay, we checked the VRRP, and that's how we can configure OSPF, guys. And what let's capture packet on this interface of gig 1, interface gig 0, and capture packet and see how they're able to exchange the LSS. So as you can see, it's sending hello packets. The hello packets, in the first thing about OSPF is to send hello packets to establish the neighbor, to find where your neighbor is. You send the hello packets, hey my neighbor, are you there? Then the neighbor should be able to reply with the, yes, my neighbor, I'm here. So after I exchange the hello packets, they will be able to now establish neighbor adjacency. Now they will exchange the LSAs. This router will send an LSA request to the other router, then it replies, then it updates, then it's acknowledged after that. And when the LS is fully when they have advertised all the LSS and their database have been synchronized, and the neighbor state should be in a full state. So it's still exchanging the LSS, so let's give it time. So this is the practical you are to implement. Then I said in the next practical we are going to implement what is called the IPsec, the VPN. The VPN help you secure your network. Like maybe you are a remote worker, you are a worker from the main company or a headquarter, and you went on a field trip or on a work trip. So you should log into your headquarter network, but through a secured channel. So that's where we implement what is called the VPN. So here we are going to use the AppSec VPN. We are going to also configure the IKE proposals, the AppSec proposals, and also we are going to configure the ACLs to allow some packets to pass through, so that in case somebody tries to connect with some network, it should be blocked. That ACL should be able to block that traffic. Still exchanging LSS. So let's check on display OSPF peer. When you display OSPF peer, you are able to see here the process ID we set to 10. The router ID is of 10.0.0.2. So like I said, the router ID, you can either set the router ID manually, or the device will automatically pick the router ID. For this case here, the device picked the router ID of 10.0.0.1. In most cases, if you don't configure it manually, the device will pick the highest loopback interface address, or if there's no loopback address configured on that router, the device will pick the highest configured IP address. Like for instance here, in this router here, we configured gig 1 and gig 2, but now it has picked 10.0.0.2 because this is the highest IP address. So it will pick the highest physical IP address or the highest loopback IP address. Then you can see here the designated router is 10.1.1.1. Backup designated router is 10.1.1.2. That is the router 3 there down there. So it's acting as the backup router. But while this router 1 here is acting as the master, because it is .1. This router here .2. That's why it has given you the backup router of that. So as you can see here, capturing packets. It has requested the packets, and the packet the neighbor has sent an update. Okay, these are what I have in my DD database. You can check and try to check if you have the same. Then it requests, after that also send a link state acknowledgement. So that's how you can capture packet on an interface and see how the OSPF negotiation is happening between the two adjacent routers. So see, just look through and see how it's able to exchange those the LSS. So thank you guys. I hope you've enjoyed this session, and let's meet in our next module, where we'll now configure the VPN.